So I'm going to record this so that if you didn't get it, you can go home and you can practice it. Because this is going to be one of your free responses, okay? The only difference is that I'm not going to present it like this because this is more like an AP question. I'm going to actually say, what are the moles? What's the molarity? So I'm going to walk you through the process, but you got to know how to do it still, okay? So the first thing that you should have paid attention to on this problem was who you were dealing with. That was pretty much, because that right there tells you what you need to do. So the fact that you had nitrous acid, you wanted to focus on the aus part, and the fact that there was no hydro. So you know it's not binary, it's automatically ternary. Ternary tells you you gotta look up polyatomic ions, okay? So we have that little sentence, ick, I ate a humongous bite, and so the us is gonna go with ite. So we're looking at nitrite. That was your first step, okay? And a lot of you guys actually did it. You did awesome. So you should have had this, nitrous acid, okay? Once you had that, then you had to ask yourself, okay, is this a strong acid or is this a weak acid? Okay, what did you guys have to do in order to figure that out? The H and the O's, right? We had to see if there were 2 or more O's than H's. So this is 2 minus 1, there's only 1. So this is definitely a weak acid. So those are like the ones that you guys are like, oh man, she's making us do it again. Okay, so we're gonna do a rice table. So when you look at that, we're gonna just set up our rice table and then we'll figure out what other information we need. Okay, so the rice table, you should have had your HNO2. Who do you always add your weak acid to? H2O. And we're gonna be making what? H3O plus NO2 with a little minus, okay? Especially my people going into AP next year, make sure you're paying attention to these little parts right here. You want to always add your charges in there, okay? They're really big necessities. If not, it's okay. I'll understand what you're trying to say. All right, so here, that was our reaction. Now the I part, we know that we need initial concentrations, okay? So we need concentrations for this line. So we don't have any concentrations here. We have grams and we have volume. So what you should have done, and most of you did, okay, was you went off to the side and you were like, somebody calculate molarity. So for molarity, you had to get moles. So you had your 3.2 grams, divided it by its molar mass, which was 47 grams. And most of you guys got 0.068, I believe, right? Okay? Ish. You should have. It's okay. Did you not? No, you. Oh. You just looked at me like it was like way wrong. I was like, no, it's that's what it is. Okay. All right. Oh, okay. All right. So we're gonna divide it by 0.3. Why did I have to do 0.3? Because it's in milliliters, so we wanted it in liters. Good. All right. So most of you guys found that to be 0.2246. Sorry, 6. Was it 6 or 4? 6. Okay. Molarity. That number is what's going to go over in our rice table. So we're going to add that to our little rice table. I'm going to zoom back into that. Move you off to the side. Okay. So we're going to put 0.226. Do we ever include water? No. We put 0, 0 every single time. You guys have that guarantee, okay, from me. So the next one is, how is this going to change? Well, the change we're going to put with X's. So our reactants do what? Go minus. And our products always go plus, okay? So that leads you to your last line. And for this one, we need equilibrium values. So we have 0.226 minus X, and we have X and we have X, because we did our math up and down. So from this point, now we're ready to solve for what? What was the big idea of our rice table again? Who do we want to solve for? Well, pH. So who are we counting? H3O. This is the whole point right here. So we know that H3O is only equal to X. This is the reason why we do the rice table, by the way. I know that some of you guys have gotten used to you just throw it in. You're like, well, it's always going to be X squared times the molarity. That's fine. But please don't forget how to use the rice table, because the rice table isn't always going to be that simple, especially with people moving on next year. Get your practice in, enjoy it while it lasts, while it's always the same way, and then next year it'll be little.
So it's just always going to be x squared?
For you guys, yes, but I am going to be asking you guys a rice table question. So just know what the pieces are at least. Does that make sense? Okay. All right. So now we're going to go ahead and use that k value that I gave you, which was 4 times 10 to the 4th. So I'm going to put 4e negative 4. Set that equal to x squared over, and remember for you guys, we're going to go ahead and say x is negligible, okay? There is that little calculation. You guys don't have to worry about it. So 226. So the way you're going to plug that in, you're going to multiply these guys, and then you're going to square root the whole thing. So if you want it in one big step, square root and do 4e negative 4 times 0.226. So you should have gotten like 0.009-ish. Okay? And that's still not our answer. If I was asking for the concentration, that's what you guys could have said. Okay? But we got to do that last little step where we take negative log of this value. And your pH ended up being 2.02. Okay? All right.